Hello, my babies. It is Miss Lloyd here to look at some polynomial inequalities today. So some of our steps here, whenever we're solving polynomial inequalities, it's a lot like just solving polynomials. Just we gotta do some checking at the end to see like where the inequality will be. So we're gonna set things equal to 0. We're gonna factor. We're gonna set the factors equal to 0. We're gonna solve some critical values. And so the critical values are the equal to sign, even though we don't have the equal to sign, it's kind of like in our minds. So those are the critical values. And then we put those on a number line, test around those critical values to figure out where it's true for the inequality, so we know where to point our arrows or throw our shade. So an example of that, it's already has a 0 on one side, so I'm going to go ahead and start factoring this. So I'm looking at multiplying, not the color I want, looking at multiplying to get -6 and adding to get -1. So that'll be -3 and +2. Because I have a 1 in front, I can just throw these into the factors. So x minus 3 and x plus 2. And again, I'm going to set this equal to 0. I'm going to push pause on this less than 0 sign, and I'm going to just find my critical values. So each of these are going to get a 0, and I'm going to solve. So x equal to 3 and x equal to -2, these are my two critical values. So these are the ones that I'm putting on my number line that I already made, and I totally already forgot that I made it. So here, on my line, -2 comes before +3. I know I've got 0 in between. It'll be a little bit closer to -2. This is just a less than sign. It's not an or equal to. So because it's not an or equal to, I know I'm going to have open dots on my critical values. And then now it comes for the time to test. So when I'm testing, I'm plugging in some of the numbers either in between or outside of that -2 and 3. I like to start with 0 because I think it's the easiest, and I'm plugging it into the original inequality. So I've got 0 squared -0 -6, so the zeros will just, again, remain 0, so I end up with a -6. This is all less than 0. -6 is less than 0. This is true, so that means that I'm throwing my shade or arrowing in between where the 0 was. So where it's true is where my line is going to go. So that means that my solution is where x is greater than -2 and less than 3. So all those numbers in between. We also did our interval notation before. So we would have -2, 3 in parentheses if we wanted to do that interval notation. I personally like this one a little bit more because that looks like an ordered pair, and that's not what we're looking at here. These next few I'm going to save for my kiddos. No offense, but I like my kids more than people I don't know. Just facts. This next one, it says solving it algebraically and graphically. It's pretty much the same thing as before. So what I'm going to do here, I'm going to get this negative out of the way. They all have that negative, and I'm not a fan of using a negative when it comes to my x squareds. I like my x squareds to be positive. So from here, I'm going to move this -1, and whenever we're moving to -1, that's multiplying, we've got to divide. And when I do that, I have to remember that I'm flipping my sign. So now that I've done that, I'm going to do some factoring. And I'm a little bit lazy, so in order to make a point though, I'm going to write this as x plus 3 squared, and we're going to have like a little discussion. And by discussion, I mean I'm going to talk because like no one else is answering me. So whenever I have something that is squared like this, if I had a negative on the inside, whenever I square a negative, it becomes positive. So -5 and -5 would give us positive 25. So because of this square here, no matter what I plug in for x, whatever's over here is going to be a positive number. And right now it's saying that I'm going to be less than 0. But I know that negative numbers are the ones that are less than 0. Positive numbers are greater than 0. So this, before I even go any further, I can see is an untrue statement. So because this is an untrue statement, it's not something that can actually happen, this is an empty set. Just like my life. Again, that I'm going to say for my kiddos. So that's one of the instances where things got a little bit weird. So sometimes you end up with a situation where it's true for all of them. So if this had been a greater than symbol before, positive numbers are always going to be greater than 0. So then we could say that that was true for all values. I can speak. I really can, I promise. And for that situation, we didn't have any x values that we could put in that would make that true, so we had really no solution or an empty set. And so another example that I'm going to go over on here is going to be this one, and then I'm going to say the other ones for my kids. So first thing I'm going to do is set equal to 0 and try to factor. Because this was under the thing that said that it could be weird, I'm just going to, actually, I'm going to make a point. I lied. I'm going to make a point. Say I don't notice things. Say I just don't notice things. I just don't. It doesn't happen. I'm going to go ahead and set these equal to 0. And so my x here will be 1, and I got it twice. So I can only put it on the number line once. I got my 1. 0 over here, 2 over here. It's an or equal to, so I would include this point. It's going to be solid dot. And then I'm going to come over here and test. I'm going to test the 0 first because I think it's easier. When I do that, I end up with 1 being greater than or equal to 0. That works out. That's awesome sauce, which means I am shading over this way. I'm going to check myself before I wreck myself, though. So I'm going to also plug in that 2 on the other side. And when I do that, I end up with 4 minus 4, and that cancels out, plus 1. And 1 is greater than or equal to 0. So that's also true. That also works out, which means I'm also going this way. I'm going both ways. I can make a joke about that, but I'm not going to. And so, because it's going both directions, that means I've got all real numbers in here. It doesn't matter what I plug in, it's all going to work out. We also have cases where we have rational inequalities. So that means that we have some fractions involved. So the first thing I want to do is try to simplify the fraction as much as I can because, I like to deal with smaller situations. So I can see that I could factor the top up here just a little bit by taking out a 3. Next, I want to find my critical numbers. And so those critical numbers, those critical values, are just setting the top and the bottom equal to 0. So I've got my numerator that I'm going to set equal to 0, and then my denominator. Now that I've got my critical values, I'm going to put those on my number line. This was an or equal to begin with, so I'm going to have this closed in. And then I got to test it. See where to throw my shade. So it would end up with 5 over negative 2, which is less than or equal to 0, so that one works out. I'm throwing some shade in the middle. And we can do the same things with negative 6 and positive 3. And we can do that off to the side if you have more room. I don't have the room. This is as far as I can go because I've done it off to the side somewhere else where you can't see. And they didn't work out, so it's just on the inside here. So any of those numbers in between negative 5 and 2, including negative 5 and 2, are going to work out for us. When it comes to the domain, and we have something that is a square root like this, the reason why this is here is because the stuff that's underneath a square root we can't have as negative. Otherwise, we would end up with imaginary numbers. So what I want to do is set this polynomial that's underneath here. I want to set this less than greater than or equal to 0. So I know if it's greater than or equal to 0, I can take the square root of 0. That's why I have the or equal to sign. I could also put any positive number under there. It may not be pretty, but it's not going to be imaginary. The things that would make it imaginary is if I had a negative underneath here. So I'm looking at where I could only be positive, so greater than or equal to 0. And then I'm going to start this whole process over again. So on my number line, got my 2 and my 5. And I'm going to test these. I've got solid dots because of that or equal to. And when I end up testing, I try testing number 3 first, or plugging in the number 3, and that doesn't work out. So I try plugging in 1, which will end up working out. And I plug in 6, which also ends up working out. So I'm going out like this. And so if we were to put that in a special notation, I would have x is less than or equal to 2, or x is greater than or equal to 5. And that's all I've got for you guys today. If you found this helpful, please like and subscribe. If you think this is helpful for someone else, then please feel free to share it. Spread the love.